Chapter 15 is about scheduling. Okay, if we have planned to produce 1,000 whatever product next month, then how can we allocate first week, second week, third week schedule, right? And also if we have multiple works, then which one first, which one next, give some sequence, right? That also schedule. Scheduling, why important in operations management? Scheduling.
Efficiency.
Efficiency. Better, faster, cheaper, right? So earlier when we talked about how can we reduce the total time, throughput time, then if we can do multiple works parallelly, then we can save time, right?
Mm-hmm.
Make faster, right? Okay. Make faster, right? So schedule better, then we can make it faster. That means we can make it cheaper too, right?
Mm-hmm.
Maybe better too. So scheduling better, make it best, better, cheaper, faster, right? So operations management. Scheduling is such. I already told you. Assigning.
Mm-hmm.
Who will do when it will be done, right? Such. And then give detailed instructions. Converting the production plan into day-to-day directive for workers. We have a plan, 1 month plan, 1 week, then give instruction when and then how many day-to-day scheduling. Objectives of scheduling. Meet due date. If we know due date next to, it's like if you take, if there is homework, to do that homework you need like 2 days. Then 1 week later, due date. Then at least you start 2 days earlier, right? So to meet due date, we know, and then we should schedule when, at least. And minimize lead time. You know, lead time is time between order and receive, right?
Mm-hmm.
If we know lead time, then we can schedule, right? So if we order now and then receive 2 days later, then we can schedule 2 days later, start something like that. Then we can reduce time. And minimize setup time or cost. Do you remember? Type A, type B, type A, type B schedule like that. Then we need 3 setup, right?
Mm-hmm.
Then if we schedule A, B, B, then only 1 setup, right?
That's
then
right.
we can reduce setup time. And minimize working process. You know, working process, something in process, right? So if we schedule right time, just like a just in time, we will talk about just in time later, then we can reduce working process. And maximize machine utilization. Machine work actually 24 hours then schedule today 100, not tomorrow, the day after tomorrow 100, like that. Then work 100%, 0%, 100%. Then the efficiency wise not good, so make something balance. Then efficiency utilization improve. Capacity and scheduling, infinite loading and finite loading. If there is capacity like this, infinite loading, you don't care about the capacity. Sometimes lower than capacity, sometimes higher. If they cannot do, then next day, something like that. And then finite, under the capacity, always under schedule under the capacity. Capacity is matter. And forward and backward scheduling. Something like forward scheduling. Scheduling each operation when system takes on order. What is this? What kind of system? Make to order or make to stock? Take order, then start. Make to order system, right?
Yeah.
Make to order system. Backward scheduling. Production activities are scheduled by their due date. That means we know the demand. We know the demand. So this one is just make, right?
Mm-hmm.
What's that kind? What is the system?
Make
Make
order.
to stock system. Make to stock. This one make to stock system. This one make to order system. Go back. Tell you. If process looks like this and then go this side is customer, this side is supplier. Make to order system, After receive order, then start work, right? So customer ask, I need something. Then this one ask part. I need a part. I need a part, I need a part, I need a part. Before receive part from upstream, they don't know when they can start, right? So this one cannot schedule. This one cannot schedule until receive part from upstream. Suppliers send and receive, right? Part. Then this one can start, right? Schedule this one first. After finish, send down. Then this one can start. So schedule. Schedule. So scheduling order this way, right? From upstream to downstream, water flow from up to down, right? So make to order system schedule this way, from up to down. So this is forward scheduling. Make to order system forward scheduling. Make to stock system, customer side and then supplier side. backward scheduling, know the due date, right? We know due date, so to meet due date, we should schedule this one first, right? So schedule this one, and schedule, and schedule here. So scheduling direction is this way. Upstream, downstream. Scheduling direction is this way, so backward scheduling. Make to stock order system, forward scheduling. Make to stock system, backward scheduling. Okay? So, forward scheduling, scheduling each operation when system takes an order, make to order system. Products are the known and product demand is unknown. Make to order system, we don't know the demand, right? So we use make to order system. If we don't know future demand, we should act after receive order, that is order make to order system. That case, forward scheduling is better. Production activities are scheduled by their due date. That means we know demand, future demand. So that is make to stock system. If it's make to stock system, backward scheduling is better. An idea for manufacturing companies that use MRP system. We will talk about MRP system later. MRP system is opposite system of JIT system. JIT system is just in time. Just in time, JIT system is made to order system. So this one, JIT system, use forward scheduling, make to order system. MRP system is conventional, traditional system, make to stock system, that case using backward scheduling. And machine limited, labor limited. Go back, capacity and scheduling, finite loading. We concern or matter about the capacity when we schedule under the capacity. If machine is limited, machine hour is limited, it's like if we have 10 machines, then each machine can work 24 hours, then 240 hours, machine hour, right? That is capacity. Then each product needs 10 hours working, then divide by, then we know the capacity, right? So machine or labor hour limited, and then if we use finite loading system, then concern about that capacity. Job sequencing, the process of determining which job to start first on some machine or in some work center. Sequencing, if we have multiple works, then which one first, which one next, and third, in terms of make it faster, cheaper, better. There are many rules, priority rules for job sequencing. You know FCFS, right? Usually we use this one, first come, first serve, right?
Mm-hmm.
If you go without reservation appointment, if you go there, then usually they serve first come, first serve, right? And SOT rule, shortest operating time. If there are multiple jobs and then each operation time, shortest one first, next, and so on. That is SOT rule. And STR rule, select time remaining. Select time means time remaining before due date minus remaining processing time. Like homework due date. If I need 2 days work for homework, if you have 7 days, then 5 days select time, right? Select time is that time. Among multiple works, take select shortest select time, work first and second, and so on. It's like urgent work, right? And STR divided by OP, select time remaining, STR divided by per operation. Okay, select time for each operation, each work, and then how many jobs remain, divided by how many jobs remain. Then take a shortest one, second, third, and so on. Due date. Close due date first, and second, and third. Critical ratio. Due date minus current date. That means how many days left, and then divide by how many days remaining, the number of work days remaining, and take shortest one, and so on. LCFS, last come, first serve. I think we never use this one. And then random order, take randomly, and so on. That is random order. Okay, if there are 5 jobs, and each job need 3, 4, 2, 6, 1 operation time, processing time, and then due date from today, 5 days left, 6 days, and so on like that. Then comparing each rules, if we use FCFS rule, then A come first, B next, and so on. So take A, B, and so on. Then total flow time is 3. This one needs 3 days. 3 days. And then after this one finish, after A finish, start B, then take 4 days. So this one wait 3 days and then start, right? So total flow time is 3, 7 plus 2 is 9 plus 6, 15 plus 1 is 16. So total flow time to finish all jobs, then 50 days. Mean flow time, total flow time divided by how many jobs? That is 10 days. And on-time job, this one takes 3 in this one meet due date, right? But this one 6 days later, but finish this one at 7, right? So 1 day late, and so on. So on-time job is A, others miss the due date, and the average lateness. This one is on time, so 0 lateness, 1 day late, 2 days late, and so on. So average lateness is total lateness divided by 5 equals 4.6. SOT rule, shortest operation time rule. Total flow time is 136. By the way, with this rule, job E 1 day, job C 2 days. So this one is shortest, and second, third, and so on. So job sequencing is E, C, A, B, D. Then total flow time is 36, mean flow time 7.2, on time E and C, late time A, B, D, and so on. So using this total flow time, mean flow time, on time job, late time job, and average lateness, due date rule, something like this. Shortest due date first, so E. Second, A, B, and so on. Then late come, first serve. We never used this. Yeah. And then random and STR rule, something like that. Then compare every rule. Total flow time, if we use FCFS rule, 50 days, SOT rule, 36, and so on. So among them, SOT rule has shortest total flow time. Of course, mean flow time shortest among them. And then average lateness, 2.4, the same. Anyway, if we can use SOT rule, then this one is make something faster. Fastest rule. So we can save time. But in real world, usually we cannot use this one. But anyway, if we can use this SOT rule, this one is shortest rule. And then always work. Always. If we can use this one, SOT rule, then that is fastest scheduling rule. Okay, scheduling n jobs on 2 machines. For example, I gave you a lecture note, right? When nowadays, when we make a copy, then just place on there and then select function, the staple function. Then maybe front and back. Then automatically do, right? I went to Hanoi. We have Troy University has Hanoi program there. So it was 2014 winter. I went to Hanoi to teach operations management. Then in the morning, I went to school. then make a copy for the lecture notes. At the time, 45 students. The copy machine doesn't have a staple function, and then also the machine was very slow. So if we do 45, make it 45 lecture notes, here maybe 3 minutes, 4 minutes, like that. But at that time, it takes like 30 minutes. Because it's slow,
and then you got to
then
staple,
staple
sort and
myself.
staple, yeah.
So, copy, done, then staple. So, if the copy machine and staple machine separate, to make this kind of lecture note stapled, we need two machines, right? Something like this. So, first machine do the job, and then it goes to second machine, and then multiple jobs like this. Then, how can we schedule to make faster? Maybe cheaper too. If there are 4 jobs like this, A, B, C, D, and then operation time for A on first machine 3, and second machine 2, 6, 8, and so on. We call this Johnson's rule to minimize the flow time, make it faster. Step 1, list the operation time for each job on both machines like this, 3, 2, 6, 8, and so on. And step 2, select the shortest operation time, and then if the shortest time is for the first machine, do the job first. If it is for the second machine, do the job last, and repeat step 2 and 3. Let's do. Okay. Operation time, 3, 2, 6, 8, 5, 6, 7, 4. Which one is the shortest operation time?
2.
2.
Do it last.
This one on second machine. So do the job A last. Do the job A last. So place job A last like this. Okay. Then this one is gone. Job A is already gone. Now, among 6, 8, 5, 6, 5, 6, 7, 4, which one is next shortest?
4.
4. Take this one, right? It is the second machine. So do the job second last. So place job B second last. And this one is gone. Okay, now 6, 5, A6. 5 is shortest. So take C. That one is on first machine.
Do it first.
So place job C first, right? And this one gone. Then B is last. It doesn't matter, but anyway, 6 is shortest. So it is the
Second,
first machine, second, first, right?
Mhm.
So job sequencing or job order using Johnson's rule, C, B, D, A. So C first, B second, D third, A last. So after job A on first machine done, then goes to machine 2. After job C finish on machine 1, job B start and so on, then total time is 25. So using Johnson's rule, you can schedule which one first, which one next. Then this one is fastest. So make faster. Any question? No question? You have practice problem. Second last page, number 1. Try. Always I say, you don't know what you don't know yet. Also, you don't know what you know yet, right? So try.